Imagine the loud voice of a cosmic announcer echoing across the universe. In the far corner of reality, weighing in at billions of solar masses, the ultimate heavyweight of doom, the black hole. And in the other corner, compact, furious, and spinning like a galactic drill, the neutron star. Tonight, ladies and gentlemen, we're setting the stage for the most extreme showdown the cosmos has ever seen. Forget your boxing rings, because this fight takes place in the fabric of space-time itself. Who will come out on top when two of the most terrifying objects in existence go head-to-head? Grab your popcorn, or maybe a radiation shield, because it's about to get weird. Let's start with gravity, because in this universe, size really does matter. Black holes don't just attract things, they capture them with a kind of obsessive possessiveness that makes even the clingiest ex look casual. Once you cross the event horizon, there's no escape. No calls, no texts, not even light can ghost its way out. A black hole doesn't just bend space, it folds it, warps it, and crumples it up like a cosmic piece of paper. Neutron stars aren't exactly featherweights, though. Take a sugar cube of neutron star matter, and it would outweigh Mount Everest several billion times over. Drop it on Earth, and it wouldn't stop until it had bored a tunnel right through the planet, punching out the other side like some unstoppable cannonball. But even that raw density can't compete with the irresistible, all-consuming pull of a black hole. In the gravity round, the champ is clear. But wait, density is where the neutron star flexes. Black holes, ironically, aren't the densest objects overall. Sure, their mass is terrifying, but spread across the vast sphere of their event horizon, their average density can sometimes be lower than water. That's right, some black holes are technically fluffier than your swimming pool. Neutron stars, on the other hand, are like the universe's compact car from hell. They cram the mass of the sun into a ball just 20 kilometers wide, so dense that protons and electrons have fused into neutrons, forming a city-sized object of unimaginable pressure. A single teaspoon of this stuff would crash through your kitchen table, your floor, and the entire Earth before you could even say, oops. In this category, the neutron star clearly outmuscles the black hole with sheer compactness. Where do they come from? Both contenders share the same violent birth story: the death of massive stars. When a star burns through its nuclear fuel, it collapses, triggering a supernova that briefly outshines entire galaxies. If the star is massive enough, its core implodes into a black hole, crushing matter into a singularity where the known laws of physics throw up their hands and walk away. If it's slightly less massive, it stops just short of that fate and stabilizes as a neutron star, frozen in an eternal state of ridiculous density. One ends up as an infinite abyss, the other as the densest possible chunk of matter that still plays by some of the rules. You could call this round a tie, since both are born from the same cosmic fireworks, just with different endings. Now, reach. How far can these monsters extend their influence? When a black hole feeds, it creates a swirling disk of gas and dust, spiraling in at nearly the speed of light, glowing with the fury of a million suns. These accretion disks can stretch for light years, spewing jets of radiation that cut across galaxies. And let's not forget spaghettification, the delightful process where any unlucky astronaut is stretched like cosmic taffy as they fall in. Neutron stars aren't sitting quietly either. When they crash into one another, they create conditions hotter than the heart of any star, forging heavy elements like gold and platinum. They shake the very fabric of reality with gravitational waves that ripple across the cosmos. Still, in terms of sheer distance of influence, black holes are the long arms of the universe, shaping entire galaxies with their gravitational might. But don't underestimate the neutron star's personality. These compact beasts can transform into pulsars, spinning hundreds of times per second while shooting out beams of radiation like cosmic lighthouses. Imagine a disco ball so precise it could keep time better than our most advanced atomic clocks. Some neutron stars mutate into magnetars, wielding magnetic fields so extreme they could strip the atoms in your body apart if you got too close. If one passed within a few light years of Earth, your credit cards, computers, and even chemistry itself would start acting, let's say, weird. In contrast, black holes tend to just sit in silence, looming ominously, occasionally gobbling up anything dumb enough to wander nearby. Neutron stars may be smaller, but they win on variety and sheer cosmic eccentricity. So, after several intense rounds, where do we stand? Black holes dominate with gravity and range. Neutron stars crush the density game and win the prize for being bizarre cosmic show-offs. Their origins tie in a draw. That leaves us with a result that's less about crowning a single champion and more about marveling at how utterly strange and terrifying our universe can be. It's like asking who would win between a dragon and a thunderstorm. The truth is, the real winner is the cosmos itself for inventing such outrageous competitors. But I'll throw the final bell to you. Are you Team Black Hole, loyal to the quiet, unstoppable heavyweight that warps time and space itself? Or Team Neutron Star, cheering for the furious, hyperactive cosmic pinball that outdances everything and keeps time better than a Swiss watch? Drop your allegiance in the comments below, and don't forget to subscribe for more battles that will stretch your imagination as much as a black hole stretches reality. Until next time, keep your feet on the ground and your eyes on the stars, preferably from a very safe distance.